Thank you. There's lots of videos in here, so I don't have to do a lot of talking, so that's great. So today I'm going to be talking about data-driven design. And data-driven design for an architecture and engineering industry like ourselves is really looking at how we're embracing data. We're not afraid of it, we're actually taking it to another level. And that's where we can really see how industries are changing and adapting very, very quickly to data. So data, I think we can all agree that it's big data and analytics are transforming the construction industry. And as Toby said, it's a slow burn. But and while data is great, making sense of it is really the answer here. So you can gather all the data you like, but actually trying to visualize it, make sense of it, and actually use it for our purposes is the real key for us, particularly in the AEC industry. So for us as a company, we're looking at data on multiple levels. We're looking at it from a campus master planning space. We look at it from, for example, in the health sector. We look at, say, where are all the hospitals currently located in Australia? Where is the closest cancer diagnostic centre? How far do people have to travel to get to that cancer diagnostic centre? Understanding the demographic of the population, their travel distances, starts our conversations with our clients about, instead of maybe spending $90 million on an expansion, maybe we should be looking at an acute facility closer to where the needs are. The use of data, both on a geographical point, understanding how people are using the cities, how people are getting the data from Opal, getting the data from Nike, understanding traffic movement, understanding our demographics is starting to become a real integral part of master planning. Buildings, efficiencies, utilisation, proximity. This is what I'm going to be talking about today, about master planning. I can talk about all of these aspects of how we're using data. I can speak for many hours about it, but really I'm just going to focus on a small part of it, and that's about master planning, how we're using data from a master planning point of view. It's the reason that I've become really excited about data-driven design is, as been in the industry for 20 odd years, and we get an RFP, there's a building available, it might be a 1960 building, but it's available, and the RFP is we need to put a chemistry chemistry group, department, into this building. And the building's not appropriate, the criteria of the building is not going to be able for them to scale, but it's available. And a lot of the RFPs that we're getting from our EST sectors, our education, science and technology sectors, our big health infrastructure sectors, it's a reactionary process. And what we're trying to do is to help our clients get ahead of the curve and sort of understand, before we just put that RFP out, let's really use the data to start informing that master planning process. So that for me has been a really big drive and one that I'm really keen to talk about. And then we can start using data from the building aspects, so we start then driving into departmental use. How many people are getting access to daylight? How are we utilising meeting rooms? Travel distances. If there's a classroom peak at Monday at 10 a.m. and we're getting these huge crush points around lifts and student call facilities, how can we use data to start flattening all these peaks and troughs out? So we're starting to, as a design firm, starting to really embrace the use of data. And then you start drilling down into proximity and efficiencies and starting to utilise that third space where those friction points occur, so we can start creating new collaboration. So lots of opportunities for the design industry to start embracing data. But for us, we're having to respond in a way that, not just having more architects, more people using Revit and the like, we're now changing our mantra. We've got predictive analytics team, we've got a data and engineering team, we've got computational designers. We're starting to evolve as a practice to start informing the design process. Data isn't the answer, but it informs the design process. And so that's what I'm going to talk about today. Just one project, one very simple project. It's a master planning project for Macquarie University. And I'm going to show you how we use that data to analyse, visualise, and then how it started to inform the design of for their master planning. Analysing data. So when you work with an existing client, you'll get a whole raft of data, and a lot of the effort for us is actually cleaning that data. That's where our data engineers are coming in now. So getting that data and really starting to crunch the data, clean it up, and start to make sense of the data. Just having the data means that you can actually go down a whole series of rabbit holes. So the first question you have to sit down with your client is ask, what is the problem we're trying to solve? Because having the electricity usage or the water usage on a building is not going to really help inform student population growth or which department should go into which particular building. So understanding the right question helps you then to define the type of data you need. So as an industry, we're actually starting to look at to complement the design team and our engineering team with data engineers who can take this data and clean it up and help us to understand it. So we have a huge amount of data available to us. And one of the things which was really interesting, so for Macquarie University, we were just about to complete, we're at schematic design. It was a 30,000 square metre building, and they didn't know who should go in it. Fundamentally didn't know who should go in it. Normally it's the loudest person in the room, one of the deans banging the table saying, I need to be in that space. But they weren't convinced. And so one of the things, we kind of did ourselves out of a job, which was a little good move. But what it allowed us to do was then take a step back and start using the data they had available to figure out the answer to their problem. So what we did is we were able to use grant funding and publication funding. We data mined the web, because it's all available on PubMed. We were able to identify all the researchers on campus within the Faculty of Science and Engineering, overlay that information, actually understand who's actually collaborating with who's writing 50 papers in the last 5 years, who's actually getting the most funding, which departments are actually getting the most funding, and start looking at these core diagrams to start understanding actually wasn't actually biochemistry who are actually doing a lot of work together, it was actually physics and astronomy. And so that allowed us to actually then reshape our master planning and really start rethinking the next 3 buildings, not the next building, but the next 3 and 4 buildings. When you're working with property managers, they always say, and whenever I walk around campus, it's half empty. These spaces aren't being utilised. You talk to the deans and say, we can never find a space. It's always crammed. So what we did is we were able to take the timetabling, overlay the student capacities and attendances, and start taking their Excel documentation and start overlaying it with dashboards, identifying it where you get utilisation amongst rooms. So what we found was they were going to build a whole raft of classrooms, and what they really lacked was teaching labs. So we were able to demonstrate there was huge gaps through their timetabling program that actually would accommodate 30-person, 60-person classrooms. And then it's all unemotional. You just put the data out there and you say, guys, there is large gaps occurring here, which we know that you can better utilise your existing campus. Don't go and build another 20,000 square metres. Start thinking about how you can use your existing campus and really look at where your stress points are. So that's how we took data and started analysing it in a very different way. It's not about student hubs and love hearts and how we're going to create this ephemeral space. It's all about, let's look at what we can do to help you with your master planning process. But just having that data in a 2D format is one thing. The next thing is then taking it to somewhere where we can visualize it. Now the FM guys very much like the use of, this is very lightweight models. We're using Rhino here, and we're bolting data onto very lightweight models. We're not getting into Revit, we're not drawing partitions and floor slabs, very simple, lightweight models. For the FM team, they can quickly see where all the high intensity labs are, where all the low intensity labs. When I'm talking about high intensity labs, I'm talking about chemistry labs, vibration sensitive spaces which require, if you're doing microscopy, or if you're doing high-end instrument needs, or it might be just high-intensity environments. So we're taking those spaces, and we're just starting, this is just us analysing the existing site. Very helpful to take all that 2D data and start bolting it to very lightweight models. Now that we have a schedule of accommodation, what I wanted to know was about student population growth in the next 10, 20 years. And again, I'm talking about education here. This is applicable to commercial, retail, healthcare. It's taking that, it's taking that data and it's saying, okay, well, instead of just reacting and doing a piecemeal approach, let's get all those projections and take the scheduled accommodation and fasten up the process of how we take that scheduled accommodation, identify it in a 2D graphical sense, and start dragging these spaces. We've just got these outline theoretical buildings here, and we start dragging these department needs. So this will be a chemistry department. We start dragging and dropping these spaces. It's very lightweight, it's really fast, and it helps us to come to rapid decision making. So, and when it starts overflowing, like you're filling up a vessel, it starts showing red through here. So as we keep, dragging and dropping, we're talking to the university. We're saying, well, okay, let's have a look at where chemistry and biology and physics and astronomy and stats and comms should go. And it starts filling up, and we're starting to look at, well, is it a 10,000 square metre building, or is it a 15,000 square metre building? Well, what we're doing here is understanding the brief and trying to firm up the brief before we start going out to market. And then with that, as we're building it, we can actually see where spaces are available. It's live, it's responding, it's rapidly responding to it, and it's something that we are doing in-house. And I'm sure many firms will be starting to do this, because this is where, as design firms, we need to be getting ahead of the curve, starting to use the data available to help us and our clients and our contractors and our consultants make better decisions. And then we take it to another level. And if this is impressive, you should get in touch with Jeremy Graeme, who's sitting at the front here. This is all his work. I'm just the show pony. So here we're taking to another level. This is evolutionary planning. So we have a very manual approach where we sit with the client and we start to move these spaces, and we start talking about blocking and stacking. This is taken to another level where we're using genetic algorithms to start applying not just space requirements. What we're doing here is we're using genetic algorithms to start applying performance requirements, such as this department and this department require high intensity labs. This department required to be associated with this, so maybe maths and stats need to be associated with environmental science. So we're applying not just space information, but performance and need information. Jeremy's developed an algorithm that allows them to, what you saw there was, you'll see it cycling through. What it was doing is it's actually running 100,000 iterations. It's evolving and learning. It's using AI to actually start looking at how we can take all that space and block and stack it in the most efficient manner with the requirements associated with it. So we'll say, look, an operating theatre and a recovery, they need to be associated together. It might be chemistry and biology, they need to be associated because they have high intensity requirements. So what we're doing is we're overlaying performance requirements and ran it through 100,000 iterations in under a minute. It would have taken me months just to go through those various iterations. Again, it's embracing the data. It's evolving ourselves as a design industry to start rethinking about our planning. And again, it informs the design. It doesn't come up with the outcome. It will come up with maybe five options, which we can then go to the client and start exploring that further. But most importantly, when this is the most important part, is that it's all inclusive. It's not just HDR sitting, going away and working this through. We do this with our clients there. So we'll have the client, we'll have the contractor, we'll have the QS, and it's all about the opportunity to bolt more and more data onto these models to start that decision-making process. It's live, it's lightweight, and so we can sit here and go, all right, well, let's look at this particular Schutzel yards and say, okay, well, let's take a moment where we go, maybe we want to change the mix from offices to, from office to commercial. Maybe we want to rethink it might be dry labs to wet labs. And as we're blocking and stacking and involving it, it's continuous. We work with our QSs to then bolt costing information on. This also can then score with site planning. You can have a contractor sitting there going, well, if we go with this type of arrangement, the site access is going to be far more inefficient, and so it then scores it down. And if we move the site building over here, it scores it higher. All we're doing is just applying metrics to our models and expanding that conversation. It doesn't go to the QS for them to come back 6 weeks later and figure out, actually, you wanted an 18-storey, it actually can only afford a 15-storey building. They're in the room, we're talking that through. So it's a very, very rapid process. So very quickly, I presented just a small element. And I think what we're showing here is the opportunities us as an industry to take data to that next level. I just want to show you a very quick movie, which shows you, as a company, I've shown you about master planning and the opportunities, how we do it as a master plan. But the other opportunities that we're seeing in terms of data gathering, processing, understanding opportunities that come up. There is a really cool dance track that goes over the top of this, but unfortunately. So here you're seeing some so this is a project we've got in Kuwait. We're looking at rapid test fitting of patient bedrooms. We're evolving the buildings. It's being scored through here. We're watching, as you expand the building, how many options we can create through one singular model. Again, all this information is sitting in a database. And then that database isn't lost. We then move that database into something like dRofus, and then we start pushing that information into Reddit. So like distances between workspaces, access to daylight, where are those, where are the high intensity spaces where we can actually create collaboration zones. This is important for hospital care. As you're moving through the space, how many patient beds can I see as I move through through a ward? Access to daylight. If you're in there for long periods of time, how access to daylight as a patient is incredibly important. Rapidly testing solar analysis. All of this is just a smorgasbord of opportunities as an industry that we have. Thank you very much.